Hi, ChatGPT and Claude have a ton of functionalities. I want to show a couple of functionalities and then I want to see if we can implement these using an LLM which is running locally on our system. So, firstly, I'm showing Claude where I asked it to create a very simple HTML page which allows me to toggle between the light and the dark mode. Now, interestingly, if you see, it is giving me this nice preview. It is giving me this code, but to me it's much more useful if I can get the direct preview of the HTML generated, and it works like magic. Next, let's look at something similar, but this time some Python code. I asked ChatGPT to create a simple Python function to plot a random data frame, and it not only generated this code, it also gave me the option to execute this, and then I was able to generate this graph from this. So we want to have this kind of functionality using locally run LLMs. We'd be using Ollama to serve the different LLM models which we can run locally. So I've highlighted a bunch of steps we need to follow. Some of them are fairly straightforward. Firstly, we want to be installing after downloading Ollama. So we can download from this particular link for the specific distribution. I'll skip the steps given that they are quite trivial in nature. And once we have Ollama installed, we can run a bunch of commands to check the different functionality and the different models which we have available. So if we do Ollama list, it lists the different models which I have. The Gemma model from Google has been making a lot of news, so I downloaded quite a few different variants of this, including the biggest 27 billion parameter model, which is about 17 GB in size, and then the 12 billion parameter model, the 4 billion parameter model. All of them are multimodal models. So we can also look at the Gemma 3 model chart from the Ollama website, and we can see that they have different contexts. The 1 billion parameter model has lesser context window, and it is also just a text only model, whereas the other three are multimodal with vision capabilities. So now we want to check if we can run these and then later on serve them up using user interfaces similar to Claude or ChatGPT. At the same time, getting such rich functionality where we can actually execute the code and get these rich artifacts. So once I've installed Ollama, I can also simply use the command line interface and run one of the pulled models. This is the biggest model which I am currently running from the Gemma 3 class of models, which is 27 billion. So it takes a bit of time to run for the first time. After that, it's fairly quick, and I am on a Mac Studio, so it's quite a powerful machine, and we can see that this model runs fairly well. So let's say that create a simple HTML to toggle between light and dark mode. It will, so if you can see that it's executed and it's giving me this code, the generation is quite quick given that this is a big model. I could have used a smaller model and the generation would have been much quicker. But as we see, this is not going to be too useful for purposes where I want to, let's say, just in Claude, I could have asked to, let's say, instead of this, so instead of a button, use moon and sun icon, and it will then change the code, which now it's writing the code, and then it will show the preview once it's sufficiently built. So you can see that it's easier if we can just directly get it in this specific window rather than here we getting this HTML in the command line, and now we'll have to copy paste this to, let's say, an editor like Visual Studio Code, and then they make the edits. So therefore we want to have a nice clean user interface, which is where Open WebUI will come into play. So we can now see that this specific demo has been built using Claude, and we'll be rerunning this demo in our local LLMs to see if we can build something similar. So to create a user interface like this, we'll be using something known as Open WebUI. So it has a very nice set of documentation, a lot of features. The installation could be done either via Docker, Python, Kubernetes, or some other tools. For my specific case, I've used the Python and Conda as the package manager. And I ran through these commands to create. So for some specific reason, it needs this 3.11 Python version. And once we've created an environment, we're just calling this environment Open WebUI, and we have activated that environment. And then we have pip installed Open WebUI, and then we are serving it. So this is after we've installed everything. By the way, let's say bye to this model for now. We want to first activate the specific environment which I have already created. Once, okay, for some reason it says that this environment is not found, so maybe I give it a different name. So let's just search for all the environments. Okay, so I had given it Open WebUI without any hyphen in between. So let me just activate this environment. Now, if I'm on this environment and I've already done the pip install, I can just directly serve Open WebUI. So now if we, right, so it says that it's waiting for the application startup. Now if we open the browser tab on localhost 3000, sorry, I think it's supposed to be 8080. Right, so if we open this on localhost 8080, it gives us this nice clean user interface, which is not very different from the default chat GPT or Claude like interface. Most similar, I would say, to the chat GPT interface. On the left side, we have the chats. Interestingly, here we can choose different models. So these models, if you notice, are the models which are the same models which the Ollama has installed for us. So we've installed with the help using Ollama, and we can see that it's currently chosen this one, but I will perhaps just move to this 12 billion parameter model. And now I can ask questions as I would previously do. So let's first try and ask the same question, which was we want to create a simple HTML page. So we want to create a simple HTML page for light and dark mode, and we want to make it minimal, responsive. For now, let's just give this rather than give all the instructions. So if you can notice, it's generating this HTML nicely, and it's putting in this code block, which is useful for us. It is showing me this collapse, save, and copy. Now, interestingly, if you can notice, it's created something similar. It's created this artifact visualization, and this works. In the first shot itself works. Now, as before, I may want to modify my query. So instead of a button, use moon and sun icon. So it will now regenerate the HTML. So you can see that how this can cut short the time needed. Otherwise, we would have copy pasted this into our editor of choice and then done a preview and then got some feedback. But this is quicker. So let's see if it's able to get this working or not. So for some reason, it's suggesting to use, so it's saying that it's used font, awesome, etc. I don't know whether this is working. Okay, this is working. The icon is not really showing. So we can keep on playing with this chat. Let me now open another chat and let's try and see the Python functionality. So before this, let me actually revert back some setting which I think I had changed. So I've gone to admin setting. There is a, okay, so it's given me this nice pop-up that this particular thing has run, but our HTML view has gone. We can just come here and click on artifacts, and okay, so this again runs, but for some reason it's not changing the icon. One of the things we could always do is to use a better model, the bigger model, which I'll do for the chats going into the future. But I hope you get the functionality. Now we come back to the other chat where we wanted to create some Python code, and I wanted to show some settings. So if I go to the settings, admin settings, and the code execution, we want to be using some Python code execution. For now, let me switch to what is the defaults. So, right, so we have changed to the defaults. And let's say that create a simple Python program to show the current time. Okay, this is very quick. Importantly, you can here see that I have a run button. If I click run, it is executing somewhere. So we'll see where it's executing. It's taking a bit of time. I think the first time it is always likely to take more time. So it's executing something in something known as the PyIodide environment. If you study more about this, this is a WebAssembly implementation. Okay, not PyIodide, iodide and Python. So it's a port of CPython to WebAssembly, and it makes possible to run Python packages in the browser via micropip. Okay, this is new to me that it's got stuck on this particular code interpreter. But anyway, so we typically get the output. Let me just refresh this chat and try and run again. Okay, so for some reason I'm not having luck. But anyway, what this will run is in a WebAssembly environment. So it will give the correct output for this specific case because this does not require any other additional dependencies imports. But if I were to use something which is not directly provided by PyIodide, then this particular code would not run correctly. Now you might think that why don't we install those Python packages somewhere? You technically could do that, but then you'll have to make the WebAssembly versions for those specific libraries. Instead, we'll be using something which is much pleasant for us. So let's go back to the settings, and we can instead use a Jupyter Server as a code execution engine. Oh, okay. I think it's the same. Settings were not changed for some reason. I wonder if I forgot to save it. Okay, I think I forgot to save it. And now if we go to this chat, let's just hope that the PyIodide engine would now run. Yes, so the PyIodide engine runs, and we are now able to see the current time. If I run it again, it is, so you can clearly see that the seconds are changing. But now let me ask it to make it slightly more sophisticated. So pretty print using tabulate. So now let's see what happens if I try to pretty print this using tabulate. So it's given me a bunch of things. If I run it, I would expect to see an error, which is no module name tabulate, because this is not installed in the PyIodide implementation which is running. So instead, now let's see if we can somehow use the Jupyter Server, the Jupyter Notebook interface, as the backend, the server version of that as the backend to run these code for us. So if we go to the settings again, and we go to the admin settings and the code execution. So they give us an option to use a Jupyter engine. I'll just use a Jupyter engine, and we can specify a URL where the Jupyter server would be running. Now there are a bunch of things we can provide, some authentication, etc. So just to keep things simple for the purpose of this particular video, I'm keeping aside some safety concerns for now. So I've mentioned a few things which we want to do. If the Jupyter notebook configuration is not generated, we can generate it using this specific line. And we can then edit this particular file. So dot Jupyter folder and then Jupyter server config.py and add the following lines to the end of this config file. So let me actually just open this. Let me just copy this path. Okay, so I already have set these specific things here at the bottom of this file. Let me just add these two also at the end. Once we have set these specific commands, so we want to keep the authentication to minimal so that we can quickly start the Jupyter server and then connect to it via the Open WebUI. So after this, I want to be running it on a specific port with the no browser mode so that it doesn't trigger a browser UI. Okay, so it did not pick up the port 8900. I think it's might have been restricted, but it's instead giving us this port 8861. So we can make use of this port, go to Open WebUI, modify the Jupyter URL, and let's save it. And now if we go back to our example, so if we now run this, you can see that it's nicely printed out this specific thing in Tablet because I have Tablet installed. But this was a simple example. Now let's see if we can get something equivalent of this. So I'll create another chat. Great. Let me just use the better model. For now, it will be slightly slow, but let's use it. Create a simple Python program to visualize a random data frame via Matplotlib. Given that the model is bigger, it might take slightly longer than before. Okay, for some reason it's creating very nice function, signature, etc. I might have created a simpler example, but let's see what this does. And we have our output visualized here, which is very useful. So let me just stop the execution. So let's say that use the dark mode Matplotlib style. And instead of using plt.plot on each of the column, I think it could have just done a df.plot and it should have worked. But anyway, let's just visualize, and we can nicely see that this particular visualization has come. So this is the power of iterative improvement, which we can quickly get using this functionality of being able to execute the code within this environment. There are a bunch of other cool functionalities which are provided by Open WebUI, including things like RAG. They also do rendering for Mermaid.js to produce nice diagrams, as well as the artifacts, some of which we have seen, which was the HTML page. So this is what I wanted to show, that we can get a lot of the functionality which the very nice interfaces and LLMs like Claude and ChatGPT are providing. We can do that locally using the given setup of Ollama for serving the LLMs, and then Open WebUI to provide various neat user interface elements to it.